Okay, guten Morgen, guten Tag to the online world. We'll start in a while, and this is to discuss the smart contracts. And the smart contracts here are not written on Ethereum per se. These are written on Impula network, which is still not available for the large public at large. However, the stakeholders and the operators who are part of the protocol have cognizance and utilizing it the way it has to be utilized for the 6G networking. So we'll start in a while, putting myself on mute. Okay, we will be discussing the IRS. So IRS here stands for Intelligent. Okay, we will be discussing enrollment. Okay, we will be discussing IRS, that is Intelligent Salient System, and particularly the use case study with 6G and the like. So how the communication is established with the protocols, particularly with carriages, which is, honestly speaking, I don't want to give it a particular nomenclature, but yes, it can be between carriages, it can be between vehicles, it can be between bodies, it can be between the understanding of the IRS protocol itself. So first of all, we'll just go through the understanding the modeling around the same in terms of how it can be tagged, and the tagging itself can be facilitated for the protocol purposes. So first of all is to establish the propagation channel, how the channel can be propagated in terms of what signals can be utilized which are not being utilized right now for the deployment of 2G, 3G, 4G. I have to get into this mode. Okay, fine, understood. So we have to understand the propagating channels for the same, which is around H04B17/391. The second we have is services making location information using location-based information parameters, that is particularly nothing but the GPS, latitude and longitude with the orientation information, that is compass. All the smart devices have compass, so you can utilize it. My favorite is northwest. I like to align my direction in northwest direction generally. But it depends. It depends upon the characterization of the other nodes in the near vicinity, because many a times northwest is not that great as compared to the southwest. So I'll rather go in the southwest direction to get the spectrum in a manner for the 6G Impula network. Then we have, so there's something called as capital letter V2P. So here the letter V is capital and P is capital. V2P is particularly, it relates to vehicle-to-pedestrians, and these are the services which can be on the blockchain service or the PaaS as a platform for particular environments, situations or purposes. Or as I said, let's take vehicle as a body also, because when we are utilizing biochemistry and particularly when we are understanding viruses, the body format is called as a vehicle. I don't know how many people know about it, but that's how the fragmentation and the tagging is done in biochemistry. So this is done. Let's understand this. So I'll be discussing two more use case studies for the 6G deployment. If you have any questions related to this, please ask and I'll see if I can answer those. So the intelligent resalient system, how it works is establishing the Jalon. Jalon stands for the word path. It's the propagation path for both the aerial and the marine terminals. Let's understand this, the trajectory. Okay. So how the transfer function is understood here. Let me look into the graphs. Quite interesting. So we need to take into account the angular deviation for sure. Okay. So establishing the IRS, that is Intelligent Resalient System. So I, perhaps the word letter I, in one of the hypotheses, take it as inter, INTER. And for the others, I wouldn't say I should be taken as intellect, because that itself holds no meaning with all these LLM models being developed, which is more to do with propagating the synthetic data and is already part of the protocol. So there is no point getting into the intellect part of it. What is important is understanding the interconnections, internodes, inter of everything, and that is equivalent to being intelligent. So let's look into the signaling part. And somehow we are trying to understand the time dilation with this, and this is very much possible on the Impula network. And we take the capital T and the small t as zero, absolute zero, not even infinity, because when we take t as infinity, the equation changes, the alignment changes. So just to align the functionality of the Impula network, we are going to keep it simple. Take both capital T and small t, the letter capital T and small t in English, which is Roman in nature. So let's deep dive into this. Okay, what are the parameters which needs to be taken into consideration when the parameters are being established is the velocity and the position. Now the position itself is going to change depending on the wind direction. So the previous historical data has to be taken into consideration along with the environmental data. That becomes very important for the simple version of what 6G use case study can be. And what we are trying to do here is computing the elevation angles of departure and the arrival for the scattering path rate. So even for the scattered thing, what I believe is to have a control unit first and get the control as a monitoring unit, and that has to be done in silos. So this has to be orchestrated in a closed environment. I'll give you an example. In simple words, if the players, so players are the candidates who are playing basketball, under the environment which is closed, and if you see their way of performance over maybe a year or so, and say 25 games were played in that particular court, you will see the results very differently when you are just taking the ambient temperature. So to develop the control and the monitoring protocols, we are trying to achieve where the control is equal to monitor, which is very different end of the spectrum. At one end of the spectrum we have control, at the other end of the spectrum we have monitoring. Honestly speaking, from the standpoint view of how science has been utilized till now, these are two different way of understanding. However, with the quantum deployment, this is very much we have the use case studies where it has been achieved with the ambient atmosphere. However, point of contention here is, can we achieve this in a closed environment? If I talk about New Delhi, which is the capital of India, there's a place called as I think it's near the cantonment area, so it's the army area. We have few places which are close-ended. I haven't visited myself, but I know about these places like Talkatora Stadium and all. These are newly developed ones. So it is in a closed environment. So in a closed environment, things are very different. So these protocols and these experiments can be conducted there in a very synchronized manner. Then we have, okay. Honestly speaking, the Doppler shift of the scattering path of the angle, it's been there for the longest time. We have to do something else. So the kind of effect, again, it's an Impula effect. This month's description of what we have been doing is being published So I'm not getting into the formulae right now and telling and opening the beans what has been done. So let it be in the public domain, and then perhaps the other folks can work on it and see for your own self how beautifully the 6G protocols can be developed or are already developed on the 6G Impula network. So channel matrix not required. So this is one. I'll get to the next one. I was thinking of discussing 3 applications today, but I will hold myself. Okay, let's look into the time domain transmission characteristics. This I think I already discussed about. I discussed about the propagation channel. So the next one is the scattering of the propagation system, which is the scattering in the ionosphere, tropospheric, or the meteor scatter. A lot of work can be done in certain layers of the atmosphere. I'm not getting into it. Maybe in the month of December we'll discuss on that. Perhaps I have the use case studies with me, but still delving on some of the parameters I want to really work on and then disclose that. And then we have, so this scatter propagation system is H04B7/22 arrangement for optimizing operational conditions. Again, it's a good way to establish the control or the monitoring protocol that is optimizing the operational conditions on a blockchain. H04W24/02. Next is, oh my gosh, how much emphasis I can put on this for the longest time. I actually talked about it very openly in the year, I think 2018, on the timeline we are in 2025, that is energy harvesting. Now, how to reduce energy consumption in communication networks is paramount right now in wireless communication networks, and that too in the Wi-Fi understanding, that is why not 2D30/70. So loads of scattering happening here and there. Okay, so IMT-2030, that talked about the propulsion group in China, that 6G general vision and the potential key technologies are there for Internet of Things to be used as an important component of 6G wireless communication, and the deployment and the application of Internet of Things are accelerated. It's already there. I mean, China is way ahead in terms of the deployment of the technologies at a very large scale. Therefore, this research, I think the research is already over right now. I will just get into the method protocol. I'm not getting into the formula because formula can be anything. If, say for example, X minus Y minus Z, it can be anything in terms of the auxiliary part of Internet of Things. We all know that people who are conversant with the understanding of how the patenting world works. And let me tell you, 6G would be the intersection of a lot of languages. It's not that one particular language is going to be the paramount language of understanding. It is particularly the understanding of what tech is all about for real, because a lot of work has been done in silos, and 6G gives an opportunity to collate the same under one protocol. I won't say one protocol, but a core protocol as to what can be established under these 6G protocols. So let's finish this ASAP. Okay, so when we are trying to understand the IoT networking of Internet of Things, that is particularly to deploy handheld devices and other devices with the right candidates. We cannot be just being doing with random candidates, because random candidates have no cognizance of how tech is being utilized or what tech is all about. So if I have to give that freedom, uh, because Impula is another operating system we have been working around, and perhaps probably very soon I would be where I have to be, and then get the phase ready for the deployment with the operators. And this would be an operating system which is which is like which is actually solving the problems of the Android we know is an open source, and it comes with a lot of problem statements. iOS has its own proprietary stuff, and Impula itself is proprietary to what is already developed till now. Okay, so what we're trying to do here is understand the geometrical analysis of the IoT macrocell aided with IRS. IRS here is how you reconfigure or reconfigurable intelligent surface, that is IRS. So it's reconfigurable or reconfiguration or reconfigure. So if you're able to reconfigure the intelligent surface, you're able to establish this geometry which is elliptical in nature. Just imagine the Milky Way. So it's a very simple example of what the space is all about in terms of the understanding of the space analogy, elliptical and cylindrical, and that geometry is emphasized or embossed onto an IoT microcell aided RIS. Now, there we are evaluating. I don't like the word computing. I always like to use the word evaluate the length, and then those length are actually put into as an input data for the impulse response for the scattered path. So if the scattered path, if we are talking about the